everybody, and welcome to our new video. And today's video is all about the Taylor series in math. And Taylor series is just like the Maclaurin series, except the graph function is being swifted over to the right side or the left side. And today's function will be cosine x. So just like starting off from the Maclaurin series, we have our function fx is equal to cosine x. And we would set it equal to our polynomials equation. But since this is a Taylor series and the graphs is being moved over to the right or the left side, so the center is pi over 2. And the center of C could be anything, but just for today, it'll be pi over 2. So what this would change is, usually we would start off by writing down C sub 0 plus C sub 1 times x, but since this is a Taylor series and the center C is pi over 2, we would actually have C sub 0 stays the same, plus C sub 1 times x minus pi over 2. And then so on of C sub 2 times x minus pi over 2 to the power of 2. So cosine x is equal to C sub 0 plus C sub 1 times x minus to the power of 2 plus C sub 2 times x to the x minus pi over 2 squared, and then plus C sub 3 times x minus pi over 2 to the power of 3, and plus C sub 4 times x minus pi over 2 to the power of all by 4 plus dot dot dot. Wrong rotation. So setting all of that aside, we will write down our function cosine x, and then when we have our x being substituted by the pi over 2, we have f pi over 2 is equal to cosine pi over 2 is 0. So our f pi over 2 is 0. Then we will prime this function right here, cosine x. Priming that, we get negative sine x. So our f prime pi over 2 would be negative 1, because negative sine pi over 2 is negative 1. Then we would prime negative sine x, then we get f prime prime x is equal to negative cosine x. Then our f prime prime pi over 2 would be 0. Then differentiating negative cosine x, we get f prime 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 x, which is equal to sine x. So our f prime 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 pi over 2 would be just 1. Then differentiating sine x, we get f to the power of 4x is equal to cosine x. So then our f to the power of 4 pi over 2 is equal to 0. So now we will differentiate our original function, this long function, then we get, actually no, before we do that, we have to set our x is equal to pi over 2. So we get f pi over 2 is equal to, so when we put our pi over 2 for the x placement, this becomes 0, 0, 0, 0, and so on. So after the c sub 0, it's just all canceled out. So we are only left with c sub 0. But from right here it says that f pi over 2 is equal to 0. So our c sub 0 is equal to 0. And now we will differentiate our original long function. So we get f prime x is equal to c sub 1 plus 2 times c sub 2 times x minus pi over 2 plus 3 times c sub 3 times x minus pi over 2 to the power of 2 plus 4 times c sub 4 times x minus pi over 2 to the power of 3 plus dot dot dot. And now it's pretty obvious that we will not have our room for c sub 0, so we will scoot it down. C sub 0 is equal to 0. Now we will set our x is equal to pi over 2. So we have pi prime pi over 2 is equal to just be left with c sub 1. Now here it says that f prime pi over 2 is negative 1. So our value for our c sub 1 is equal to negative 1. Now we will differentiate this function of f prime x. So then we have f prime prime x is equal to 2 times c sub 2 plus 2 times 3 times c sub 3 times x minus pi over 2 plus 3 times 4 times c sub 4 times x minus pi over 2 plus dot dot dot. Perfection. Then after setting the x as pi over 2, we have f prime prime pi over 2 is equal to 2 times c sub 2. And right here it says that f prime prime pi over 2 is equal to 0. So our value for c sub 2 is equal to 0. Wait, I don't know why I put negative in front of the sub 1, but we'll just pretend like I didn't do that. So then so now we differentiate this function now. We will go all the way up to, we will differentiate these functions until we have f to the power of 4x. So after differentiating this function now, we have f prime 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 x is equal to 2 times 3 times c sub 3 plus, oh wait, I'm supposed to have a squared here. Another mistake. So we have now 2 times 3 times 4 times c sub 4 times x minus pi over 2 plus dot dot dot. So now after setting our x is equal to pi over 2, we have f prime 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 pi over 2 is equal to just 2 times 3 times c sub 3. And here it says that f prime 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 pi over 2 is equal to 1. So we have our value of c sub 3 as 1 over, I think it was, 2 times 3 times 3. Now we will differentiate this function now. So we only have f to the power of 4x is equal to 2 times 3 times 4 times c sub 4 and then plus dot dot dot. And now setting our x as 2, we have f to the power of 4 pi over 2 as 2 times 3 times 4 times c sub 4. And the plus dot 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 represents having x minus pi over 2, and then in front we have all of these multiples, but since we are putting pi over 2, they all just cancel out. And now here it says that f to the power of 4 pi over 2 is 0. So our value for c sub 4 is equal to 0. And now we won't be needing all of this note here, so we will remove them or erase them. So now after having all of these notes, we will simply just replace them into our original function cosine x. So we have cosine x is equal to c sub 0 is 0, nothing goes there. C sub 1 is negative 1, so we have negative 1 times x minus pi over 2 plus c sub 2 is 0, so nothing goes there. C sub 3 plus 1 over 2, c sub 3 is equal to 1 over 2 times 3. So we have x minus pi over 2 to the power of 3 over 2 times 3 plus c sub 4 is just 0, so nothing goes there. And just by looking at this pattern, first term we have x minus pi over 2 being powered by 1. But then our next term we have x minus pi over 3 to the power of 3. That's just plus 2 for our next term's power. So next one, it's very obvious that we would have a power of 5. And also notice our first term is, starts from negative, positive, then our next term must be negative. And looking at this very carefully, our, do you call this denominator or numerator? This x right here, I don't know, but we'll just call it a bottom, and our bottoms is actually 1 factorial, and this is 3 factorial. So since this is 1 factorial, 3 factorial, using some of common sense, our next term's bottom would have a 5 factorial. And just going on with our list, we would have a plus 7 factorial, and then on the top we would have x minus pi over 2 to the power of 7, then minus plus dot. So here we just have found our answer for Taylor's series of cosine x, turning that into a polynomial but in a shifted graph function. Thanks for watching, and see you guys in the next video. Bye.